So welcome to Electronics 6 and you are watching Signal System lecture series. And today the topic of discussion is the energy and power of the discrete time signal. So in the previous class we have seen how to calculate the energy and power of a continuous time signal. Okay. So in this class we will study about the energy and power of the discrete time signal. Okay. Uh, then we will calculate the energy and power of these signals. Based on this, we can tell that it is an energy signal or power signal, or it is a neither energy nor power signal. Okay, so let us start our discussion. So the energy, as we have seen earlier, is that the energy E of a signal x of n is defined as, this is the formula for finding out the energy. Okay, or we can write here, uh, or we can write uh, it is limit that we have seen uh, that n tends to infinity summation of n equal to minus n2 plus n xn square. Okay, this is how we find out the energy of a discrete time signal. So we are finding the energy of a discrete time signal. So in the discrete time signal, the energy, if energy equal to finite, okay, energy equal to finite, then it is a, called the energy signal. Okay, and also the second condition is that that we have seen is the power of the this energy signal equal to 0. Okay, so if energy is finite and power equal to 0, then we call it as a, it is an energy signal. Okay, the average power of a discrete time signal is the formula for finding out the average power of a discrete time signal. Okay, so let us see. Uh, so actually this formula will be useful for calculating the energy and power of a discrete time signal. For infinite GP series, the formula is like this. Okay, so it is 1 plus a plus a square up to that is infinity. It will be 1 upon 1 minus a, provided that a is less than 1. Okay. Similarly, if this a is greater than 1, the value for this formula is infinity. Okay. Similarly, finite GP series. So for finite GP series, this is the plus a to the power n. Then the formula is 1 minus a to the n plus 1 divided by 1 minus a, provided that this is age less than 1. Okay. But similarly, for age greater than 1, the formula is this one. Okay. So this is actually we are going to use in this for calculating the energy and power of a discrete time signal. Okay. So let us see. And the return on the power energy of a unit step response. Okay, so we will calculate the energy and power of a unit step response. Okay, so let us see that we know that the unit step equal to, so u of n, what is the unit step? So unit step equal to that is the u of n equal to 1 for n is greater than equal to 0 and 0 otherwise. This is the unit step function. Okay, so let us calculate the energy and power of this function. Okay, so the energy of a signal x of n, that is minus infinity to plus infinity x1 square. Okay, and then if we put the signal is valid from 0 to infinity. Okay, so we can write 0 to infinity, or that is the minus infinity plus infinity un square. So we can write it is n equal to 0 to infinity un square. Un square means it will be 1 plus 1 plus this one. So it is going to infinity. Okay, so the energy of a signal is infinity. Okay, so similarly we can find out the power. Let us see. The average power of discrete time signal. This is the formula for finding out the average power. Okay. So here calculating the x of n. X of n equal to u of n. Okay. X of n is the u of n. So this is the formula for finding out the average power of a discrete time signal. So it will u n square. So let us see. Let us see. So it will be. You can see over here. So un square means it is the limit. In this case, it will be from a limit n tends to infinity, that is 1 upon 2n plus 1. Okay, so it will be summation of n is from 0 to n. Okay, so 0 to n, so 0 to n, then it will be square. Okay, so square, it will be 1. Okay, so this is the summation of n equal to 0 to n, this will be 1. Okay, what is the value for this one? This will be n plus 1. Okay, so that will be n plus 1. So it is written over here n plus 1. and it is n plus 1 divided by 2n plus 1. Okay, so that will be how much? So it will be numerator and denominator we can divide by n, so it will be 1 plus 1 upon n, similarly 2 by 1 plus n. So we put n equal to infinity over here, so it will be 1 plus 1 by infinity. Okay, so it will be 2 plus 1 by infinity, so this term will be 0. Okay, so this will be 1 by 2. So this is the power of a u of n. So you can see the power of u of n equal to, it is finite. Okay, so the power is finite and energy equal actually infinity. So this is the given signal is a power signal. Okay, so what is the condition for power signal? The power should be finite, so it is power equal to finite. Okay, and the energy equal to infinity. Okay, so we have seen that energy is infinity and power is finite. So this signal is a power signal. Okay, so let us see some more examples. So there are you have to find out the power energy of the following signal and check whether the signals are power energy or neither power or no energy. Okay, so these are the 4 questions we will solve. Okay, this is the 4 question that will be solving this in this video. Okay, so first one is here, you can see x of n equal to 1 upon that is the 1 upon 3 to the power n u of n. Okay, so now what is the energy of a signal? So energy of signal is minus 0% x of n square. Okay, so let us put over here. So you can see summation of n equal to minus 0%. So 1 upon 3 that is the 1 upon 3 x of n equal to 1 upon 3. So u of n, so u of n equal to 1, you can write over here 0 to infinity. Okay, so that will be 0 to infinity, u of n equal to 1. So I can write as 1 upon 3, you can write as square to the power of n. Okay, so that is 1 upon 3 square, it will be 1 by 9 to the power of n. Okay, so now what is the formula? So for the formula is here, this is the formula. So 1 plus, that will be a plus a square, so up to infinity. Okay, so this is infinite GP series, and a is here less than 1, a is here less than 1, a equal to 1 by 9, so it will be 1 minus a. Okay, so 1 minus a means so a is 1 by 9, so 1 upon 1 minus 1 by 9, so it will be 9 by 8. So energy equal to, we have find out that energy of the signal is 9 by 8, so it is a finite. Okay, so let us see the power. Now the power equal formula is like this. Okay, so power equal to this is the formula, so it will be 0 to n. Okay, 0 to n 1 by 9 to the power of n. So what is the formula for finding this power? So it is a finite, you can see it is a finite GP series, so 0 to n. So formula equal to 1 plus a plus a square. Okay, that will be a to the power of n, it will be 1 minus, okay, 1 minus, and that is will be a to the power of a to the power of n plus 1 divided by 1 minus a. Okay, for a is less than 1. Okay, so it is a 1 by 9, a is here 1 by 9. Okay, so let us put this formula. So 1 minus 1 by 9, that is n plus 1 divided by 1 minus 9. Okay, 1 minus 1 upon 9. So what will be now? So it will be this term equal to 9 by 8. So taking outside 9 by 8, so limit n tends to infinity 1 by 2n plus 1. Now this will be 1 minus, you can see 1 by 9 to the power n plus 1. So I can write 1 by 9 to the power of n plus 1. Okay, so now I can write over here. Okay, so it will be 9 by 8. Okay, so let us put the limit values. So limit here, it will be limit will be limit n tends to infinity, so it will be 1 by infinity. Okay, similarly this term will be 1 minus this infinity means it will be infinity, so 1 by infinity. Okay, so this term will be 0, so 1, this term will be 0, so it will be 9 by 8 into 0, so this term equal to 0. Okay, so you can see the power equal to 0 and energy equal to that is a finite. Okay, so this energy equal to between 0 to infinity, so it is finite, and power equal to 0. Okay, so if these two conditions are made, so this is a energy signal. Okay, this given signal is a energy signal. Okay, so now the signal energy is finite and power is 0. The energy in finite, power is 0, therefore the given signal is a energy signal. Okay, so this is our first example. let us see our second example, that is e to the power j pi by 2n plus pi by 4. So energy here, this is the formula for n finding out the energy. So it will be e to the power of j, that will be e to the power j theta. So we have seen in the previous class also. So e to the power of j theta equal to means cos theta plus I sin theta or j sin theta. Okay. So it will be e to the power j theta mod. So this will be cos square theta plus sin square theta. Okay. Then it will be square. So I will j theta square. So it will be 1. Okay. So sorry, this is the root over. Okay. So that will be 1. So e to the power that will be cos square theta plus sin square theta, it will be 1. So this is the, that is why we can see this will be 1. Okay. So 1 means this would be infinity. So this is energy equal to infinity. Similarly, the power, this is the formula of power. So you can see here it is also, this will be 1. So what is the, that will be 1. So that is 1. So what is the, this value? This value equal to, so minus n to plus n. So if you calculate here minus n to plus n, so minus n to plus n. Okay. So minus n to this minus 1. Okay. Minus n to minus 1. Then 1 to n. Okay. This 1 to n, you can see samples 1 to n. If you sum over here, okay, so that will be n. Okay. Similarly, minus n to plus minus n to minus n, that will be n. Okay. And this is 1. Okay. So if we sum it, it will be 2n plus 1. Okay. So this is the summation. Okay. So if we, this is all 1. Okay. All 1. So if we take summation from minus n to minus n to minus n, so that is n. Okay. And 0, the one sample is there. So 1 to n, if we sum it over, that will be n. So n plus n, that will be 2n plus 1. Okay. So 2n plus 1, this will cancel out and we have the 1. Okay. So you can see energy is equal to infinity and power is finite. Okay. So it is a power signal. Okay. So this given signal is a power signal. Okay. So this is our second example. Let us see our third example. Okay. This is the sin pi by 4n. Okay. So this is the energy of this signal. Okay. Energy equal to this one formula. Next equal to, if we put, this will be sin square pi of n. So sin square theta equal to 1 minus cos theta divided by 2, cos 2 theta divided by 2. So that will be infinity. Okay. So that will be infinity because this actually what will happen is that, so summation, if we have summation of n equal to minus infinity to plus infinity cos theta, or in this case it is cos pi by 2n. Okay. So this will be 0. Okay. This term will finishes and it will be 0. So we have now summation of n equal to minus infinity to plus infinity 1. So that will be infinity. Okay. So infinity energy, we have got the infinity, then power. Okay. So power, the formula is like this. So 1 minus, similarly, it will be 1 minus cos 2 theta divided by 2. Okay. So you can see over here, so half we have taken outside. So limit n to the 1 upon 2n plus 1. So this is equal to 0. Okay. So we have seen equal to, that is the summation of n equal to minus n to plus n. Okay. Cos pi by 2n. Okay. Cos pi by 2n. Okay. So that would be this term will be finished. So this term will be 0. So we are left with this half will be taken outside. The summation of n equal minus n to plus n 1. Okay. So that will be this is, we have seen here, it is 2n plus 1. Okay. So 2n plus 1, 2n plus 1, it will be 2n plus 1. So it will be half limit n tends to infinity 1 upon 2n plus 1. Okay. This is 2n plus 1. Okay. So 2n plus 2 will cancel out. So we are left with half. Okay. So we can see energy equal to infinity, and power equal to finite. That is half. So this given signal is a power signal. Okay. So this is a power signal. Energy is infinite and power is finite, means the given signal is a power signal. Okay. So let us get into our last case. It is e to the power 2n into un. Okay. So in this case, you can see energy equal to xn whole square. So it will, if we put here over e to the power that is that 1 to, likewise it will go to infinity. Okay. So that is the 0, e to the power 0 is only 1, then e to the power 4, then e to the power 2, 8. Okay. Likewise it is go to the infinity. So this term actually it will be infinity. Okay. So there is power also, what we have, same, it will be infinity. Okay, so that is the power. We have seen that the formula is this one. Okay, so that would be infinity. Okay, so if we put over here n equal to infinity, the actually uh, the power equal to infinity. Okay, this is the means finite power series formula. Okay, finite power series, where here you can say a is equal greater than 1. Okay, that is why this formula. Okay, so now if we put here n equal to infinity, that would be infinity. Okay, so you can see in this case energy is infinity and also power is infinity. Okay, so now this signal is a neither energy nor power signal. Okay, so this signal is a neither energy nor power signal. So this is how we calculate the energy and power of a discrete time signal. And based on the calculation, we can tell it whether it is an energy signal or power signal or neither energy nor power signal. Okay. So that's all the energy and power of discrete time signals. So in this lecture, we have seen how to calculate the energy and power of a discrete time signals. Okay. So thank you all. Thank you for watching this video. Okay. So if you have any doubt, please free to ask me in the comment section. Okay. Thank you all. Have a nice day.